Professor Kargel, thank you so much for accepting our invitation and welcome to Space Month Cambridge. Professor Kargel is joining us today from Tucson, Arizona. Before we begin, I'd like to introduce you to our audience in case they aren't familiar with your work. Professor Jeffrey S. Kargel is a senior scientist at the Planetary Science Institute. His current research includes field studies and remote sensing investigations in the high mountain Asia region, where he studies hazardous mountain processes such as glacial lake outbursts, floods, and landslides, especially where they affect villages and infrastructure. Professor Kargel is also a planetary scientist and works on Martian cryospheric processes and landscapes, as well as aqueous and organic geochemistry of icy worlds from Earth, Mars, Saturn moons Titan, and other icy moons of outer planets. His work deals with future life resources borne by asteroids and Mars, and of possible extraterrestrial habitats of life on Mars and Europa. Professor, do you really think extraterrestrial life existed on Mars and Europa before the human species came into existence?
Whether it exists now or in some long ago past time, I really don't know. But the conditions seem to be either now or in the past conducive to the existence of life. It really boils down to how hard it is for nature to make life. And we have exactly one example, one planet where we know that life was made. Now, you can say, well, there are billions of planets out there, including other stars, trillions of planets. And of course, life has to be common, but we don't know the odds, the exact conditions whereby life originates. But it seems like it's not far-fetched to think that life originates pretty easily in, given millions of years, maybe even much less. And that there have been millions of years available, even billions of years, for relatively warm, aqueous conditions in the subsurface of Mars, sometimes on the surface, and in Europa, Enceladus, other places. So I think, I don't know, give me a coin and we'll decide whether there's life there or not.
Well, thank you for that response. So to a layman still grappling with the world that's on Earth and things like COVID, the mining of asteroid feels a little far-fetched, if not something for the distant future. However, from an innovator or an engineer's perspective, we aren't that far away from it, are we? So when we talk about mining and processing technologies, what kind of technologies are we going to be looking at? Are they going to be robotically operated? Are they going to be manually operated? Are they going to be similar to terrestrial equipments and mining technologies that we have on Earth? And how far away are we from actual distribution of space raw materials?
Those are some good questions and a good preface to the questions also. Regarding the preface to your question that, to the layperson, it seems far-fetched, far off in the future. I really don't necessarily disagree with that layperson's perspective. I'm not specifically a technologist, I'm a scientist. And so, the technology for, building a tunnel through a mountain to me seems really crazy, wild, far-fetched, but I happen to know that people build tunnels through mountains. The technology to build an automobile to me seems wild, crazy, far-fetched, yet it's done. The technology to build a rocket that can go into orbit around Earth seems wild, crazy, far-fetched, but now we see that not just several nation states, but also now an increasing number of private enterprises either are already doing it on a routine basis or are clearly directing their efforts in that way. So I'm always impressed with what engineers can do, given the motive and given the financial resources. It's maybe not a coincidence, that's an understatement, that it was billionaires who were able to afford to develop commercial enterprises to enter Earth orbit. And for asteroid mining, I would say it's, the case seems to be clear that it will be commercial enterprises that do this. It seems that, I'm really impressed with the national space programs, ESA, JAXA, NASA, with quite a few asteroid missions so far, cumulatively, since the 1990s. And so, maybe NASA and ESA and JAXA are the originators of the concept of exploring asteroids, and their data provide the some of the critical information necessary, and also Earth-based astronomers provide the critical information necessary that will be used by asteroid mining entrepreneurs. I don't really see that NASA or ESA are going to rush out and start mining asteroids. I think it's also pretty clear in my view that unless there is an overwhelming political motive, sort of a international rivalry among nation states, I doubt that humans are going to be the miners. So, we can sort of put away some of those Hollywood films where, rough and rugged miners are out there on some asteroid mining it. I think it will be robotic. I think the exploration needed to find the right asteroid will be robotic. Now, there's a huge gap between finding the right asteroid to mine and then mining it. Yeah. To me, that still seems quite far-fetched. If I shouldn't use the term far-fetched, far off in the future.
Yeah.
It seems to me, because we're talking about not just putting a spacecraft in orbit or hundreds of spacecraft in orbit like commercial enterprises have done. We're talking about launching a large number of spacecraft to find the right asteroid to mine. That right there is a huge endeavor, because it's actually much harder to get spacecraft to escape the Earth's gravity well than it is to go into Earth orbit. And then the communications with a spacecraft that are, millions of kilometers, tens of millions of kilometers away are daunting relative to communicating with an Earth orbiting spacecraft. And so just the exploration part, I mean the economic exploration part, is daunting. But when you talk about processing, maybe millions of tons of ore to bring back thousands of tons of the good stuff, that's a pretty daunting exercise. It would definitely take an Elon Musk or a Jeff Bezos or a Richard Branson or some other billionaire out there. I'm not personally not really a tremendous fan of there being these hundreds and hundreds of billionaires, but they're the ones who are going to push this through, because it's not going to be done by a $10 million capitalization startup company. It's just can't.
If I may, as a scientist, how do you feel about that? The fact that investment is more important than the technical feat of actually mining asteroid?
Well, the two go together. You need the investment to enable the technological feat. Earlier you asked, will the mining equipment be similar to that on Earth? Well, on Earth, more often than not, you have this big wheeled or tracked vehicle, in an open pit mine or a big mechanical borer, and there's a human being operating that piece of equipment.
Yeah.
So we're talking about maybe similar kinds of mechanical equipment, but automated. And since we're talking about long light travel time, you know, minutes to tens of minutes of light travel time, it's not going to be like, the kind of automation where, somebody's sitting in a room pushing a lever this way and the machine goes forward and pulling it back and it goes backwards. But beyond that, all the maintenance, and if we're talking about lots of physical stuff that's being physically disaggregated or, heated to high temperatures or, the various processing steps, there's going to have to be maintenance of the equipment, and that's going to have to be automated. So I think we're talking about a really challenging situation. And I don't think we're anywhere near ready for that. But I'll tell you this, back in 1994, when I wrote a paper on the economics of mining precious metals from asteroids, um, I didn't even know whether there would be a regolith, that is a soil-like layer of loose rubble on the surfaces of small asteroids or not. I was kind of hoping there would be,
Yeah.
but the evidence really wasn't clearly there. During the 1990s, I put together some observations which suggested that there, despite the theoretical models that said, no, there will be no soil layer, the gravity is too low. I was saying, well, I think the evidence says that there is, because you have these, like the Canyon Diablo meteorite that made Meteor Crater. It was one big chunk that came down and made the crater, but there are thousands of pieces of it strewn around for tens of kilometers, 100 kilometers around. And those pieces must have been just loose material laying on the surface. So that was sort of the seeds of a hope that there would be a loose regolith layer. Well, now we've seen quite a few asteroids. Itokawa was really an eye-opening to me from the Japanese Hayabusa mission. Um, but there have been several others where we've seen soil-like layers, loose, disaggregated stuff on the surface. Why is that so important? Well, it makes mining them a whole lot easier if you can just like take a magnetic rake. What's a magnetic rake? Well, a rake that's magnetic, and it doesn't exist yet.
Yeah.
And so I think a magnetic rake will be very important to go through these soil-like layers and collect the stuff that's already disaggregated. Um, so, some of the mining equipment will be similar to what we have on Earth, in terms of the physical processing of the material. But in terms of mobility, it's going to be very, very different because, if you take inflated rubber tires rolling over the surface, well, the first bump it comes to, it's going to fly off into space, or else you'll have to just creep along at, a centimeter per second or
Yeah.
something like that. It just doesn't really make a lot of sense to have tracked and tire based interfaces between a mobile vehicle and the surface if we're talking about a small asteroid. If we're talking about like a main belt asteroid, a much bigger thing, even something like Eros, near Earth asteroid, the gravity is starting to become significant enough that you might start using some more familiar type vehicles, but automated, and everything automated. Yeah, okay, maybe two or three astronauts, I don't know, to do the maintenance that the automated things can't. But there are not going to be teams of dozens or hundreds or thousands of miners on an asteroid. That's just, you know, Richard Bezos might think, well, we're going to have, you know, huge colonies on the moon. And so we'll have huge mining operations. I don't know. I haven't heard him speak to the matter. You should interview him. Elon Musk, Richard Branson, interview them.
I think I need to interview their teams because I don't think generally the people who lead are the brains behind the mission. They are the funding behind the mission, but the brains behind the mission are usually the engineers, aren't they?
This is true. This is true. But, you know, there's no arguing with, you know, say what you want about some of the billionaires, but you look at, you know, Elon Musk's achievements in rocketry, for example, and it's just, oh, that's another thing that in 1994 I could not have imagined. I mean, it was way beyond to think that you could launch a rocket that looks conventional upon launch, but then it lands on its tail so that it can be reused, and
Yeah.
then the guy does it and does it again and again. And also the you know, Musk's work with electric cars is I think going to be very, very helpful, having that brain power, those engineers, that team. I mean, these people who have funded these expensive commercial exploits definitely have assembled brilliant teams of engineers. And so, yeah, it's going to take someone like Musk or Bezos or Branson to pull together the teams and the capital to support the teams, and also the sharp leadership decision making that will make the difference between success and failure. But you know, it seems daunting to me.
So when I was reading, I thought I came across that the most cost-efficient method of sending asteroid mining equipments into outer space was to manufacture it in outer space itself instead of sending it through a payload, because the cost of sending it would be far more expensive than creating the equipment in outer space itself, maybe through 3D printing. So when we talk about things like space mining, space construction, or space infrastructure, or maybe something as simple as maintenance, do you think it creates a segue to the creation of a space colony one day?
I guess if you're going to create a space mining venture, it might be helpful to have the experience of a space colony first, or if you're going to create a space colony, it may help to have a space mining venture first. So it could be a chicken and egg situation. But in terms of the production of equipment in space, you know, presumably I don't know if you're talking about in low Earth orbit or on the surface of an asteroid. Those are two very different things. In low Earth orbit, yeah, there's the advantage that if you have the feedstock, the basic raw materials in low Earth orbit, then energetically, it's easier to bring near Earth asteroid stuff into low Earth orbit than it is if you're going to be consuming a large part of the asteroid mass than it is to launch it from Earth into low Earth orbit. Just the energy, the delta V, change in velocity, is favorable. And, you know, the good old rocket equation that gets you that delta V. So, yeah, so then I guess we're to the point of talking about space mining to get the stuff to do the 3D printing or whatever manufacturing you're going to do. I'm actually quite, before I get on to making the equipment on the asteroids, I want to say something. I really want to say this. Um, there are some science fiction enthusiasts, and we all know that science fiction has a way of turning into reality.
Yeah.
So this is why I have to take it seriously. Um, the There are science fiction enthusiasts who imagine taking asteroids, near Earth asteroids, and bringing them into low Earth orbit or maybe a high Earth orbit. I'm really not a fan of doing this. And I used to be. I used to be in 1994. And I wrote about it briefly, I think, in my 1994 paper, or maybe in a presentation I talked about it. But Carl Sagan
Yeah.
uh, became aware of my paper on asteroid mining and my comments about bringing asteroid mass into low Earth orbit to mine it there. It would be, maybe easier to do that. And he wrote, it was a handwritten letter. It was shortly before he passed away. He wrote a handwritten letter, and it was very impactful on me. He said, if you have the technology to take an asteroid and move it into low Earth orbit, then you have the technology to create a weapon of mass destruction. There's also the matter of maybe accidents
Yeah.
happening. But that matter really affected me. And I am really not in favor of moving asteroids around. Um, it would be a weapon of mass destruction, with plausible deniability.
Yeah.
And, we just have way too many weapons of mass destruction already. And, for the same reason, I used to be a fan of producing, having space solar power produced in Earth orbit in large amounts and microwave beaming it to Earth where you need it, maybe in remote localities. But again, of course, you would, if you did that, you would not want the microwaves tuned to the water vibrational frequency, because then the atmosphere absorbs a lot of it.
Yeah.
And you want the energy to be transmitted and received where it would be used. And it sounds great, sounds wonderful, like really super green energy. And that's why I was in favor of it. But, the idea of a weapon of mass destruction, it's like you only need to retune it a little bit, and then you've got a weapon that interacts with biological materials. And so I'm very deeply concerned about space activities that would almost immediately likely attract the more nefarious impulses of human beings, especially big governments that have ulterior motives in mind. And so for that reason, I'm not a big fan of doing a lot of heavy industry in low Earth orbit. Like by that, I mean enough to supply, a whole city with energy, um, because that can be turned around as a weapon on another city. Um, and I'm not a fan of moving asteroids around. What I am a fan of, I'll say, is mining asteroids, doing it in situ. So if you're going to be doing the 3D printing of equipment, do it on the asteroid, using the resources that are on the asteroid, if that suits the the material that is going to ultimately be mined. I mean, if it's a metallic asteroid and all there is iron, nickel, metal, with trace elements that you're interested in, then it might limit what you can 3D print. I mean, you wouldn't have the rock forming oxides, but maybe you do. I mean, it depends on the asteroid.
Okay. My next question is actually very closely linked to what you said about bringing large asteroids to the lower Earth orbit. It's about the world of simulations. So I was reading up a couple of articles written by space entrepreneurs and space enthusiasts, and they were talking about the whole idea of simulations. And they said that the best way to practice asteroid mining is to bring an asteroid to the lower Earth orbit and to practice on it and to get better and then to improve their technology. So I was going to ask you about the world of simulations that when I was reading up about the Mars 500 mission, I read that China, ESA, and the Russian Institute for Biomedical Problems essentially selected 6 candidates and made them stay in a simulated spacecraft and landing module for 520 days to see what impact the human body would have if it stayed in outer space for a long period of time. The aim of that mission was to see if humans could survive in a Mars colony. So I'm assuming asteroid mining would also require running similar simulations before we can actually send our technology out. So what are the possible simulation options? Are they going to take place on Earth? Or would it be something like getting an asteroid into the lower Earth orbit? And how much do you think it would cost to run these simulations?
Okay, well, simulations involving human beings. Um, I think this is what the China, ESA, Russia um, activity involved. If I understand, do I understand that correctly? Yeah. So I think the premise there is that human beings will be the space miners or the Mars colonists. I would be uh, more enthusiastic about the Mars colonists, or at least the Mars explorers, whether they're actually colonists or not. Um, uh, because, well, first of all, there's no um, way that we can, the more military minded folks amongst us can turn a Mars colony into a weapon against Earth. Okay, so I would be very eager to see that happen. And 500 days simulation, especially in space, in orbit in a space station, would be really important. And the Russians already have done, they've already had astronauts up for, close close to that amount of time. And so, space station activities, just to look at the human biological response would be important. And, it might be useful to um, have astronauts in low Earth orbit in a space station for an extended, for many months, like 9 months, typical of a Holman trajectory to Mars, and then land on the moon, and make sure that they're functioning well and able to work on the moon's surface. That would be not so incredibly different from landing on Mars. And then build, if you're going to be doing 3D printing of habitats and machinery, do it on the moon using lunar resources. And if you're going to be producing rocket propellants, the lunar South Pole, the polar regions have ice deposits in them, and as well as other icy molecular substances which could supply carbon and um, hydrogen, nitrogen, various volatiles. So you can do a lot with that. And it's got the silicate materials, and it's got, small amounts of iron due to solar wind blasting of um, iron-bearing silicate rocks, and also due to micrometeors, some of which are iron nickel. And so, there's a whole host of elements to work with, and minerals to work with on the moon that would be, different from those on Mars, but, you adapt the 3D printing to the available material. So I think that's where a simulation would make sense. I am, as I mentioned, I am not a fan of taking an asteroid into low Earth orbit and doing practice mining on it. I am absolutely not in favor of that. So, but go to the moon and practice.
Yeah.
and integrate it with long duration weightless conditions, or have a spinning space station and have maintain them at 1/6 G like the moon.
Yeah.
Um, yeah, so I think there's a role for the simulations, definitely, especially if you're going to involve humans in some capacity on an asteroid for mining, like overseeing the automated equipment and troubleshooting. Yeah.
So I feel like you have already answered this question, but I'll still go ahead in case if you want to add something to it. So, speaking strictly from a scientific point of view, how important are asteroids to the fabric of the universe? What I mean by this question is, what are the possible consequences of meddling with nature in such an ultra hazardous environment? Looking at Earth, it is evident that humans have set a bad precedent for themselves when it comes to resource management. Plus, the feat of mining asteroids is far more challenging simply because you can't just dig a mine and abandon it like you'd do it on Earth. What are the risks of performing asteroid mining activities, and is it riskier than other space activities?
Boy, that I can see why you started with that vast question about the fabric of the universe. Yeah, it's your questions are maybe not quite that vast, but getting close to it. Yeah. Okay. So yeah, we've talked about the challenges, and by challenges, each challenge has an associated risk with it. If humans are involved, then the risks include risks to human life. If it's purely automated robotic equipment, then the risks extend to that equipment, and depending on the degree of obstacles encountered, it can be a risk to the entire enterprise, to the economic viability of that mining enterprise. So each of the risks is very is huge, and so that's one reason why you want to minimize the human involvement to the fullest extent possible to reduce that human risk. And there's also the matter that imagine having a very expensive, almost entirely automated enterprise going on, but it's designed so that you need 3 astronauts there. Um, what if the automated equipment functions beautifully, but there's a problem with the habitat and you lose the astronauts? Then you lose the entire operation, maybe. And so by relying on human miners, it it magnifies the risks in some regards. You can turn that around and say, well, the automation is really hard if you're going to automate everything absolutely, including all of the maintenance. And so by not including some humans, that is putting the project at risk. And so, that's way above my competence to answer. That's definitely a matter for the engineers and the financiers to address. But there are, you also mentioned that humans have been pretty poor steward of Earth's resources, and I agree definitely with that. And so, when I mentioned to my wife about this interview, she says, "Well, are people going to mine asteroids and treat asteroids as well as they've treated the Earth?" And that is a pretty powerful statement. The Earth is definitely suffering, and it's our home planet. And we're through not just mining activities, but mining is in that mix. Um, we're re-engineering the Earth's operating manual, and we don't even know what we're doing to some extent in terms of the impacts. And so, yeah, I don't know if we'll deal with asteroids better than we have with Earth. Optimistically, one could say that by extracting more of our metals from asteroids, then that eases some of the pressure on the Earth. And I think that's a pretty powerful argument. In itself, it's not sufficient because there are all these other issues about, I brought up the matter of moving asteroids. Are we going to abuse that technology? Um, are we going to get into a wild, wild west, in the sense of the American West in the 1880s, like in my state of Arizona, where, there were free-for-alls and shootouts and, there was law, but little meaning to the law, no adherence to the law. What is the future going to be in outer space? I mean, already we have Elon Musk and Jeff Bezos in a tweet war. Well, okay, if that's as bad as it gets, I guess that's pretty good. But what happens when billions, trillions of dollars worth of economic productivity is in competition with one another? What happens to the tweet wars get elevated? So these are issues that I don't know how to resolve them. I don't know if they just happily get resolved by proper behavior of human beings as we go into this new Star Wars world, this new Star Wars solar system. Maybe Star Wars is the wrong one to use from, if optimism, maybe Star Trek.
Star Trek.
Star Trek, um, peacefully exploring, strange new worlds. So, yeah, big issues, big issues, big technological issues, big sociological issues. As far as humans, simulations with humans are concerned, we've had both the Russians or the Soviets and the Americans have had some serious interpersonal issues in long duration flights among astronauts. You can say that that's to be expected. And you can say from an optimistic standpoint that, yeah, there were issues, but they worked through them. Nobody killed each other, and they did their duties. They did what had to be done to make their mission successful. And that's about as good as it gets, even in sometimes in a domestic home environment. You want people to get along, and so there are issues, and you work through them. And so one can take a positive view on that, but still human sociology and sexuality, they're very, very important. And they have to be dealt with properly, whatever that means. Yeah.
So, since you were talking about consequences of our actions, my last question is about space debris and how asteroid mining can lead to the creation of new space debris. What advice would you like to give to an asteroid mining company as a scientist to ensure that the usage of space remains safe and sustainable, and that to a certain extent, space still remains a pristine environment?
Rule number one, don't bring asteroids into low Earth orbit and start messing with them.
Yes.
Because if you have 100-meter diameter asteroid and you break it into 1,000 pieces, 10-meter pieces, that's a 10-meter bolide coming into into the Earth environment. Well, it might blow up in the atmosphere if you're lucky. It might reach the surface. And a 10-meter sized bolide does a lot of damage. It's not going to end life on Earth, but multiply it by 1,000, and you've got a big problem. But also, maybe a lot less dramatic than that, but still a serious problem, is if you've got machines that are crunching up asteroid material and pieces are flying every which way, I would say low Earth orbit is just destroyed as a place where we can have satellites and human beings. And so don't bring low Earth asteroids into low Earth orbit. Rule number one, not to be abused or modified in any way. But the problem of space debris also exists even if you do asteroid mining in situ. If you can imagine, again, crunching up pieces of the asteroid, like I mentioned, a magnetic rake. Well, what about all the stuff that's not magnetic that you provide some momentum to, and it starts moving off, and maybe it comes down, maybe it goes into orbit around the asteroid. Just in general, it may create a difficult environment. But also, what about the ultra fine stuff? Not the stuff that's going to hit that human operator in the head and ruin the mission, but not even the sand size material, but stuff that is micron sized. We already know from the moon, when astronauts walked around on the moon, they stirred up the dust. Some of the dust electrostatically levitated.
Yeah.
And I think that electrostatic levitation likely is pretty important naturally on asteroids. As impacts happen and debris clouds are raised, the fine stuff can levitate and move around. And I think that's probably been important in sediment transport on asteroids. But the electrostatic levitation, if you've got an electrostatically charged cloud of stuff, what's that going to do to communications? What is that going to do to putting dust where you don't want dust to go, in mechanical and optical devices? What is that going to do, to the success of the mission? I think that's potentially an important matter to resolve. I think that's something that engineers working on Earth or early operations on an asteroid can figure out quickly. So I don't think that's going to be a showstopper. For one thing, if it's electrostatically levitated, it's electrostatically charged. That means you can use a charged device and maybe clear it out. But that's something for the future. It is an issue that among many others, the thermal cycling of asteroids from extremely hot to extremely cold, and all that kind of stuff, that also is an issue for the moon and Mars to some lesser extent.
So, Professor, before we part ways, what would you want your audience to know about the world of asteroids and the future of space?
Well, I do want to end with a fairly optimistic slant. I think that it would be, depressing is the wrong word, but I think it would not suit humanity best if we are stranded on Earth, especially an Earth that we mess up as a habitable place. I do think that asteroids are a stepping stone to places even farther, to the Star Trek view of things. I think asteroids are a stepping stone, even more than the moon is, much more than the moon is. The moon can play a role, but I think asteroids are where it's at in terms of getting rocket fuels and silicon and iron, nickel, carbon, all the stuff that we need to build our, Star Wars, Star Trek future. And asteroids are fascinating all in their own right. And that's mostly where, as a scientist, I come from, in terms of being, in some cases, little pieces of microplanetary cores, like the asteroid 16 Psyche that NASA will be visiting soon, the metallic asteroids, planetary crusts, microplanetary crusts. And, they're basically represent multiple different experiments, natural experiments in planet formation, microplanet formation, and microplanet differentiation into crust, mantle, core. They're just fascinating objects and extremely diverse, which ultimately will be to asteroid mining's benefit. But in the near term, like for that first operation, it means a really challenging job of exploring, like economic exploring, I'm talking about, for the right asteroid to get the most bang for the buck, or rupee, or whatever your currency is.
But Professor Kargel, thank you so much for your time today. Lovely time talking to you.
And likewise, I had a wonderful time talking to you, and good luck to this whole audience. And I hope a few of you will make asteroid mining happen, but in a good way, in a very positive way, positive for humanity.
And
Thank you.
not violate rule number one.
Yeah, don't violate rule number one. Yes. Okay.
Absolutely.
Thank